We are streaming. This is Made Up of Wires. We are talking about decompiling Castlevania Symphony of the Night. We have been working on several different weapon functions, but today we're going to do something a little bit different, at the start at least, and we're going to go through some functions that haven't been named yet and try to figure out what they are. And this is fun because we actually get to play the game, which we don't do a whole lot of so far on this channel. We've mostly been just looking at assembly code and how we can decompile that back into C. But today we'll play the game a little bit and see if we can name some functions. So the Castlevania Symphony of the Night decompilation project's goal is to build a set of C source code that will compile back to the original binaries that were on various versions of Castlevania Symphony of the Night. We've primarily been working with the PlayStation 1 version, but the PSP version has proved extremely useful in finding a lot of matches that we weren't necessarily able to easily get with the PlayStation 1. The source code for the two versions appears to be 99% the same, so a lot of times we can decompile something for the PSP and then backport it to the PlayStation 1 without any code changes. It's a little more difficult to go the other way, starting with the PlayStation version, based on compiler settings that were used when the games were built. SOTN.z.dev has different information about our progress. You can see various graphs of how far along we are in decompiling different objects. We're not working on every object yet. There's some tooling that's in progress to help extract various parts of the game so that we can rebuild and build faster and easier. And so until that tooling is done, we're working on the areas that have been started before starting anything new. So the main game engine is in progress. There's, I believe, one function left in the main game engine to decompile. That function, if I recall correctly, doesn't exist in the PSP version. There's the Richter program, which is when you're playing as Richter in the prologue, and that has been completely decompiled along with all data related to it. We've been working on weapons quite a bit. There's 12 weapon functions remaining. All of them are in some state of progress. We worked on one yesterday and got about halfway through, and I didn't end up working on that anymore last night, but did go back to look at the progress of all the remaining weapon functions and found one that I was just had some register mismatches on, and fixed those up and submitted those. So now we're down to 12. And then there's several stages. We're going to be looking at ST0 today, which is the prologue stage. And the way that these objects work, or these files on the disk, there's a main shim that gets executed that's similar to the C main function. That loads the Dracula program, which at a particular address, and that's called an overlay. And so everything above that address is controlled by that Dracula program. That Dracula program then loads one of the character programs. So it starts out with Richter.bin. There's a alu.bin for Alucard as well. I haven't looked specifically how the weapon overlays are loaded in, but those are loaded in as well at specific addresses, and I think those flip depending on what you have equipped. And then there's a stage overlay where details about the stage, the rooms, how you transition to other rooms, as well as all the enemies for that stage are loaded. And so in each of the stages themselves, we have a set of entities, and those entities are, among other things, they might be, and we're going to look at some of the breakable objects. But the enemies are entities, and they're compile directly into each stage, which is what makes it difficult for modders to take an enemy, for example, and move it to a different stage, because all of its data and code are at different offsets within the stage binary itself. We're going to look at some of those functions. One of the goals in this project is to be able to extract enemies and different elements much easier, so modders can move enemies around and other elements like that. And we see between the stages there's a lot of shared code, so it should be relatively straightforward as stages are decompiled, that some of those entities can be rerouted. If you want to know more about the source code, there's a link at the top of SOTN.z.dev that will take you to the GitHub repo, and there are diligent code reviewers who are looking at pull requests as well as maintaining the tooling and other things like that, and you can follow the progress there. There's also a link to the Discord server where we talk about different things that we found and things that need to be worked on, that we'd like to work on, ideas and different research mods for the future, things like that. So like I said, I think today we're going to do something a little different than just straightforward assembly to C decompiling. We're going to go through and see how some of these functions integrate into the stage, and look at some of the ones that haven't been given a name yet and just have been given an address offset as their temporary name, and see if we can determine what those functions might be, specifically some of the entity functions that are the main state machines for different entities. So I have DuckStation open, and I'm going to be playing primarily in DuckStation. Oops. Make that visible instead of invisible. And DuckStation has a nice debugger window where we can set breakpoints and other things like that. I wanted to set up either Clang's LLDB or GDB to connect to DuckStation so that I could step through code for this demo. Unfortunately, GDB was not cooperating with me, and LLDB, I couldn't get MIPS ELF files loaded. So I'll work on that, and hopefully in a future stream we can do that. But the DuckStation debugger that's built in gives us enough tools that we can make inferences without having a full debugger that allows us to step through C code. So if I unpause this, we're just playing the game. This is the retail US release. I'm definitely not the best SOTN player in the world, but I can, I can get around, and of course miss that jump every time. So when this is running, we can go back to the debugger and pause, and that'll show us exactly where we are in code. So we're at some address that has offset 8000. This is going to be somewhere in the Dracula program, based on where that address is, and we could go back and find that function specifically, but I'm not too interested in that function at the moment. I want to see some of the functions that are specific to stage 0. So to do that, I'm going to go look for some of the unnamed functions. I'm going to go to my terminal, and I'm on the wrong page. The terminal. I need to update the window that is being shared with OBS. Give me 1 second. There we go. So in the first thing I'm going to do is look for functions that have been unnamed that take entities as their first argument. So I'm just grepping for things that start with func and then have an entity argument in them. And I get a series of them that have been decompiled, but these are all things that haven't been given a name yet. And so we want to hopefully figure out what some of these are. Often when a function takes an entity as its first argument, that function acts a lot like a method would in an object-oriented programming language. And I'm not a Rust programmer, but I noticed that Rust basically does the same thing with its methods for objects. Python does something similar. That self keyword is also used in Objective-C, for example, which hides that self is the first argument to each of its methods when it compiles them. So I'm going to take these, so each of these values at the end of the func is the address that it gets loaded to in memory. And so I'm going to take each of those and make a breakpoint for them in the DuckStation debugger. And I'm going to have some window management issues, but we'll get this done. I don't know what any of these are. I do know what a few of them are, actually, and have kind of set this up so that we'll hit some of them. In the DuckStation debugger, I have a menu. I'm paused currently, which stops emulation. And then several options at the top. The plus is going to allow me to add a breakpoint, and I can add a breakpoint for execution, reading a memory address, or writing a memory address. And we can look at a read a little later. I don't know if I have a save state that will allow us to quickly get to one of those reads, but we could try it. So I'm going to take that name and that last part of the name, which is the address. I'm going to copy the address, go back over to the DuckStation debugger, and add a breakpoint. Unfortunately, you can't see this window, but there's a simple dialog that allows me to put in the address, which will then show up. Oh, of course, OBS is not showing an updated version of this either. There we go. So in this breakpoints area, I now have a breakpoint for the address that I just added, which again was from the name of that function. Those function names are generated by Splat when it's extracting the code, and it does that so that you can tell where it was in memory. So I'm going to go through and add a bunch more. I have, it looks like about 10. There are other ways to do this, and if you do have a debugger configured with the built binaries, you could actually go through with a visual debugger and mark those lines that you're looking for and mark those functions, but without having that set up, we can do it with just the built-in debugger here. There are other emulators which have built-in debuggers as well. I chose DuckStation just because it was the first one that I felt comfortable with its debugger, and I haven't looked at the state of PCSXR. I also want something that can allow remote debugging in GDB and other things like that as well. So now I have a bunch of addresses, and anytime the emulator gets to one of those addresses to execute, it's going to pause the game. And we can go back to the game and unpause. And unfortunately, my emulator window is also frozen. There we go. So when I unpause, we'll start playing. And actually, we hit a breakpoint almost immediately. Let me get rid of that one because I happen to know what that one is. So I'm going to remove that particular breakpoint so that we can get out of this and go back to the beginning of the stage. And we actually hit another one along the way. I'll get rid of that one as well. I'll add these back so that we can see what they are. But it kind of shows you how, when those functions are hit, the emulator will pause. So I'm going to go up to the attic. And we hit another one. This one did I realize we hit this one before? Yeah, we did. So we've hit a third one now, this D838. Actually, no, I don't have this one in my list as things that will be hit along the way. So let's see what that might be. So somewhere in that jump up to the attic, that high jump, uppercut, we hit this breakpoint, and now we can step through one at a time. And one of the things I notice is that as these frames are redrawing, there's some fire that's being generated. So when that candlestick was there, candelabra, was in place, this function wasn't being hit. But as that candelabra is breaking, that function is being hit, and once it goes away, that function is no longer being called. So let's go back over to a terminal and see what that might have been. I'm going to pause DocStation. So that was func 801 AD 838. My dog is obviously excited about something. So I'm going to look for where that function is in ST0. So here are some interesting tells for names that have already been defined. So if Dracula's first form is defeated, we're going to destroy this entity as it is. And that kind of gives us a hint. What might this be where after we've destroyed Dracula, we want to get rid of this? Then we have the state machine. It's a very simple state machine. If we're at step 0, we're going to initialize this entity, and we have the address of an entity, which we may be able to figure the name out for as well. We're setting the current frame, and we're setting the velocity as well, and the velocity is a -1, so falling. And then finally doing an animation, and when we get to that animation, we're destroying the entity as well. So this could be one of two things, and we'll go back to DocStation. When we're it could be the fire, but I think it's actually the broken pieces of the candlestick. So we hit. It starts when the candlestick is broken, and we can kind of see in the frames. Unfortunately, the rendering is in flight, and so we're not getting the full frame when we're pausing. But we can kind of see the pieces falling down, and they're falling down possibly with a velocity of 1. And another hint that this was the pieces rather than the fire was that we kept hitting, or we stopped hitting that breakpoint once the pieces were gone. but the fire was still being drawn. So we'll go up here and we'll see if this one does the same thing. And we still hit that same breakpoint. So I'm going to just write a note to myself in this function that this looks like it's the candelabra pieces. All right, and we'll get rid of that breakpoint so we can continue on. Sometimes, oh, I got rid of the wrong one. So now up here, we'll see something similar. I actually got rid of one that I didn't want to get rid of, so let me add that one back. There is a very similar function here. When I destroy one of these busts, we hit another breakpoint, and that's at 328. And I will try to carefully break one of the candelabras without breaking the bust at the same time. Actually, this one is, this is only breaking the candelabra. So perhaps I don't have the, there we go. So this is 328. And so I'm going to go back over and look for that as well. And so we can follow this through. Again, there's a state machine that's set up for this particular entity, and depending on the type that's set, we're going to initialize and set a particular animation, set up different rendering, movement, and collision. And once it's done, the entity is destroyed. There was a second one up here that I need to find. Oh no, it was the 5.2 or the 5C that was up here as well. So two of these we were able to find related to vessels that were being broken, and whether those are just these particular, the bust and the candelabra, we'll have to figure that out. So I'm going to get rid of this 328 so we can keep going. We still have several of these that have not been triggered yet. And that could be that we just haven't hit that part of the program. It could be that those functions are just superfluous and not actually used. But let's go into the Dracula fight, and I'll see if I can beat Dracula, but also, of course, you can beat Dracula. But also if we can trigger any of those other functions. lost my cross.
Die, monster! You don't belong in this world.
It was not by my hand that I'm once again given flesh. I was called here by humans who wish to pay me tribute.
Tribute? You steal men's souls and make them your slaves.
Perhaps the same could be said of all religions.
Your words are as empty as your soul. Mankind ill needs a savior such as you.
What is a man? A miserable little pile of secrets. But enough talk. How about you?
Alright, so we've hit another one. This is at breakpoint 774. This isn't one that I've hit before or been looking for. So let's go and see if we can find that. So I'm just trying to see, as I'm looking through this, is there anything obvious that would point to what this might be? This debug comment, can't get effect works, may indicate that this is a particular effect. One thing I want to see, so this is the point in the stage where the background's going to break up and start being pulled into a vortex in the back. And that may be what we are looking at. And so let's see if there's any other tells. So we have 42 primitives that we'll be working with. So 42 is that's what, 6 and 7? Or 6, yeah. So if our grid, as we're pausing, is a 6 by 7 grid, it's very possible that that it is that vortex effect. So we'll count that and see if we can tell. The other hint is this decreased brightness. So when we get to these later steps, we're going to be decreasing the brightness. I'm assuming until it gets down to 0, which also is a hint that it is those tiles. So let's slowly work through each of those frames, and we will see. So basically, every time I unpause this breakpoint, excuse me, we're going to be waiting again until this function is executed, and this function is executed effectively every frame of the game. And sometimes you'll see slowdown in Symphony of the Night, such as when you get a life vessel or other things like that, and there's a lot of effects on the screen, and that's because the game is taking longer than one frame to execute all of the code necessary to draw those things, and so it can't keep up, and you get a lag. So we're gonna, sorry, seizure warning. So Dracula is gonna be transforming, and around the same time, we should start seeing the background break up. Dracula transforms before the background breaks up. There's some cool effects that you see kind of when stepping through that you don't necessarily see his shadow glowing oversized. And we haven't started the breakup yet. Oh, actually it has. There's a quick flash of it, and unfortunately the way that this is being rendered, you can't necessarily see. But towards the middle of the screen, you'll start seeing pieces of the background falling into the background. And so my guess was that because we had 42 primitives, that this was going to be a 6x7 grid. And I can't see how tall it is. It's quite possible that we do have 7 tiles at the moment. And when those tiles go away, possibly a different entity is going to be used for the others. But let's keep going and see. No, there's already others being pulled in. So it may not be the background. It may be, it may not be. Unfortunately, I think I'm going to get pounced on. I would like to see if I can get a Hydro Storm off while this is going. There we go. It is quite possible that this... Nope. So it does look like it was related to that background being pulled out. Going back to look at that function again. What threw me off was that this was being broken into 42 primitives, and it looks, and possibly only 42 are displayed at any time. I'll have to go look at that. So actually, we're allocating 5C primitives, and everybody knows that I'm not using a calculator right now, that 5C is 92. So 92, what are factors of 92? Oops. And there are no even factors, is that right? So I mean, obviously 2, so 2 would be 46, 4 would be 23, and 23 is prime. So that probably makes sense, and not every... It probably isn't a grid, a strict grid. Now that I'm thinking about how it kind of faded into the background. And so we could go through this code and try to figure out how they are deciding what each of those tiles is and what its arrangement is in that grid. But this certainly does look like it is likely where this is. And actually looking at this a little closer, there is this initial loop is going through 47 of the primitives. And then going through the next 42 primitives using slightly different logic. So that would get us to 87, and there's 5 more that are not accounted for. So I'll add a note here as well that this is likely the background. Yeah, hi Critifar. Yeah, we're doing some documentation. Basically going through DuckStation, setting up some breakpoints, and trying to figure out what some of these functions might be being used for. And so we set a breakpoint early on and found some of the destroyed portion of vessels. So as the candlesticks are being destroyed, we get rid of the original candlestick entity and replace it with an animated entity that's being destroyed in the process. I had found another one along the way this morning, which may have not been decompiled yet, which are the busts that are up in the attic. Those are a separate entity as well when those get destroyed. So let's go back to DuckStation and try to finish this out and see if we can hit any more of these breakpoints that are there.
No, this cannot be!
No, we didn't hit any of the others. So I did most of what is possible. There is a small window. It'd be relatively hard to hit. We could try to hit it with some save states. Where if you've destroyed one of the candlesticks as Dracula is transforming, that those pieces of the candlestick will be destroyed before they hit the ground. We could try to trigger that particular case, but I do think that would be a relatively difficult thing to do. For a game player at my skill level, I should say. We can try it. It would, so I'd have to be able to save all the candlesticks and make sure that they don't get destroyed prior to Dracula's transformation, which means not using Hydra Storm and probably not using Cross. So that might prove futile. We'll try it though and see if there's anything there. So I'll reset and we'll try to get there. I don't recall if that was. It was one of the addresses that ends in 28. So I'm going to pause and add those breakpoints. Okay, here we go. Oh, interesting. So we hit one of the breakpoints at offset 774. This wasn't intentional, but these function names. So at the beginning of the stream, I talked about how overlays work. When a stage is loaded in, it's loaded at a specific address. The game engine will read the file and basically take all the bits from that file and just stick them at a particular address and everything afterwards. And so when you're going through a room transition, for example, any of the red doors, the reason that you have to walk through that room is because the game is actually streaming in that next overlay and replacing all of the code from the previous stage to the one that you're going to be going into. So when that happens, the functions at various addresses change, and the code that's executed there changes. And so we just happen to hit an address that was being executed for the stage select screen. That also is an address that's used in the prologue for that background effect. We don't need that breakpoint though. And the same thing here again. We hit another one, same thing. This 838 I will need. I'm going to get rid of it for now so that we can get into the stage. The toggle breakpoint feature in DuckStation does not work for me. I don't know if it's a bug or if it's supposed to work the way it does, and I just don't understand it. But I always have to remove my breakpoints and then add them in again. I should probably file a bug or see if there is an open issue. So I'm going to add that 383 back. And I'm going to, in the background, I'm going to open this in my terminal as well and make sure, try to figure out which one of these functions that was the one that I was interested in. It is the 383. So if you weren't here when I was talking about it before, if we look at the if we look at this particular entity function, we can see where it's being called as well. One of the things that happens is if these candelabra pieces are breaking and falling while Dracula is defeated, they should be destroyed. And so we have maybe a 1 second or so window to both defeat Dracula, destroy candelabra, and defeat Dracula at the same time. And so that's kind of the case that I'm trying to hit. And I don't expect to be able to do it, but we'll give it a shot and see. This is like the opposite of a room glitch or other thing like that, where you want to use one of these bugs to your advantage. We just want to use one of these bugs to see if that's we can trigger this particular code, just for research. If I destroy this candelabra, we'll hit this breakpoint. This is actually the 328 breakpoint. 328 and 383 are very similar. And I think I have been getting them confused. I don't think I will need to break here, but it may help us with timing to have the debugger pause. Let me see if this 383. Sorry, in the background, I'm looking at where these are referenced. So 838 is referenced right now in data that we haven't decompiled yet. So it's one of the entity updates that is done. So this is a list of entities in order. The order that they're in specifies their ID, So this would be entity ID 24. I'm going to look to see if what the macro name for that is. And we don't have one yet. I don't have a good search for that. But what I think we'll do is, after this is done, we'll look at some of the remaining ST0 code and work on a decomp for that for the last half an hour or so. So we're going to try to trigger this. And I'm going to get rid of 328 for now. Oh, there's a 314 that we're hitting that I hadn't noticed before. I'll come back to that one later.
Die, monster! You don't belong in this world.
It was not by my hand that I'm once again given flesh. I was called here by humans who wish to pay me tribute.
So I'm going to have to watch very
Tribute?
closely.
You steal
kind of
men's
estimate
souls
when,
and make them your slaves.
Perhaps the same could be said of all religions.
When that last hit
Your
is.
words are as empty as your soul. Mankind ill needs a savior such as you.
What is a man?
Along the way, I'm
little pile
creating
of
save states so I can
secrets.
try to get back to this.
But enough talk. How about you?
So whenever he's over here, I just want to avoid attacks so I'm not destroying these. Drat. I lost one, and I wanted the other one for. I'm gonna reload. I wanted the other one for the. Oh, we did. So we hit 838 here. And let's see what. So this may be the fireballs. So a lot of these functions are reused for multiple things. And so, based on the parameters, one entity or another might be drawn. And so we think of them as different things, but in the game, they're treated the same. And so this looks like possibly the fire that's hitting me and falling. And so it'll take a little while to get through all of these frames, because this will be updated over and over. Each one of these, it looks like, yeah, each one of these fireballs, or the explosion effect, is particles. As they fall, they call into this function. And so they should be falling basically one frame, or one unit of velocity every frame. And there's a lot of them. This would be another thing if this attack was going on, and this might be an easier way to trigger this particular behavior. If this was being executed if this attack was being executed when Dracula was defeated, we would hit this condition as well. And we could step through this. It's actually probably a good, a nice thing to step through to show like how the assembly relates back to the C code. So our entry into this function is here, this load upper immediate value, and what this is doing is loading that address for whether Dracula is defeated or not, and putting that value in a register called V0. And then that value is going to be compared against the value 0. And in this case, it's not going to be 0. The one quirk of MIPS processors is that they always execute the code immediately after a branch instruction. So we're still going to execute this next line, but then we should jump, and we didn't. Curious. Maybe I wasn't tracking it closely enough. So along the way, there's a few other things where we skipped past this. This is a function call to 801B584C, which is better known as initialize entity. And then we're going to be calling into a function to move the entity. And later on, there's another function call immediately after, and that's to animate the entity. I think that's all I'm going to do in this space for now, because going through and debugging at this level without having the symbols and being able to map it back to code is tedious, and I think I've gotten what I want to get out of it for right now. So I'm going to shut down DuckStation, and let's get started on one of the remaining functions that is in ST0. So ST0 is the prologue. What's funny is internally within the Decomp Discord, it's easy, weapon 30, weapon 55, ST0, NO3, NP3. I think of, I don't often think back to the game and what particular objects those are in the game, what stages, what weapons, and things like that. But then I'll watch Dragon Blitz do speedruns, and he knows all the weapon names, all the stats, all the lore, all the other things like that. And I was watching a stream, I think that he posted yesterday to YouTube, and he referred to the entrance when Alucard first comes in as NO3, which is the name of it. And I've spoken with Aldrich on the stream before, doing decomps for some functions in NO3. And so the modding community and randomization community are well aware of some of the quirks that are there. So I'm going to be looking at the extracted assembly, and I'm going to specifically be looking at ST0, and looking for the assembly files there, and I'm going to sort those by size, and we'll find the smallest one. I use awk to extract the size and the path, and we do have some small ones there, which should go pretty quick. Maybe we could put a timer on these and see if we could speed run them. So we'll start with this one. We can see if there's any other references to it to get an idea of what it might be. So nothing in existing decompiled code. And so there are no callers for this function that I can see. So we see this in the PlayStation version, but not so much the PSP version. There's dead code that exists in the game that was compiled into the final binaries, but is never executed, and doesn't exist in the PSP version. So I am going to grab this function. I will do this as a speed run. The speed run is for my own amusement, but the rules are I don't need to get it needs to be a perfect match, so it compiles to the same code that the original compiled to. But it doesn't need to be perfect or ready to be checked in. Let's see. I do need to grab that assembly. So we're using decomp.me for decompilation. There's already presets for Castlevania Symphony of the Night. I had been doing these fast ones. So this is a small function. Just because it's small doesn't mean it's easy, and just because it's large doesn't mean it's hard. I had been doing these small ones within weapons, and my context is currently set up so that I mostly have references to other weapon things. So there may be some things here that are missing from my context. Why do I have the stopwatch overlay on already? Let's see, I want to get rid of that. We'll reset the timer. And go. So it is relatively small. I'm going to do the things that I typically do, which is set up the project in a way to get rid of any warnings or errors, and I'll do my best while going fast to narrate along the way. So there's fall entity and move entity, which are functions that I don't have in my context. Oh, I'm going to pause the timer. No fault of my own, but OBS is not sharing my window again. So let me fix OBS. I just updated OBS the other day, and I wonder if that's the cause of some of these problems. Alright, so let's we'll keep the timer going. And start. So, like I said, some of these I don't necessarily have, so I'll have to look up the function signatures for some of these, which is going to slow me down a little bit. That looks like it's a void. And move entity is probably the same. So the decompiler will come through, and when it sees functions that it doesn't have a declaration for, it'll try to figure out the signatures, but sometimes it can't. When GCC comes through and compiles, it is going to possibly reuse registers that would typically be used for arguments if it doesn't need those for arguments. You wouldn't see that necessarily with a non-optimized version of the game, but since that's what we're working with, we have to work within those constraints. So this is a slightly think we have all the context figured out. So I'm going to re-decompile and grab an updated version. It still didn't like the fall entity. It didn't like any of those. So we can't really rely on the decompiled version at the moment. But we have all of these in the context, and we can get rid of this. Oh, it didn't like my context. Let's figure that out. I had this in place for being able to build both PSP versions. There we go. And the PlayStation versions of the same code. Odd that the PlayStation version was upset with that. Alright, so we have, this is a little different than the others. We've primarily been working on functions that have an entity passed in. In this case we don't, however. So we're passing a unsigned 16 array, or pointer to an array. I see that this SP10 is going to be a collider, so I'm going to replace that right away. var s1 being a pointer to that collider is going to be unnecessary, because we can take a pointer whenever we'd like. Oh, but this is interesting. It's actually going to be a collection of colliders. So it looks like we have an array, and that array is going to be of size 4. And SP10 is going to be a collider array, 4 colliders, which is a little different than is typically done. It's fun getting back into stage code after being in weapons so long. This may be written like this, but it also may be actually a pointer that increments past. These G API calls, they need to be replaced with struct access as opposed to directly accessing the address for that function. I actually got a little too far in because we're not compiling yet. And so let me back up a little and get things compiling. So on line 44, we want the address of that. And there's some SP10s that I didn't replace. Line 50, we have a void pointer. This pointer var s1 underscore 2 is going to be a pointer to a collider, and that will probably be able to go away. Um, 52, we're looking at the effects here, which is the first field of the collider structure. 86. Temp S1 is also going to be a pointer to a collider. And again, it's looking at the effects. So we'll find that declaration and update it as appropriate. Most of these are going to be able to go away in the final version. They're just array access. but while they're here, offset 18, I don't know offhand. So those are defined in game.h. Offset 18 is also unknown 18. So I'm going to change this to array access, and that should get us almost there. Last one is this declaration. All right, so 57%, not the greatest start. I don't see anything obviously difficult to start off with. A lot of times there's functions with a lot of the geometric math that will trip me up, but in this case that's not happening, so hopefully we can figure this out relatively quickly. This is not already at 8 minutes. This is not going to be a record-setting decompilation, but that's okay. They can't all be. So here we have a bunch of assignments that ultimately culminate here as this temp A0_2. These, when they're passed to check collision, are often named X and Y. So I'm going to start there and kind of back into what the other values that are going into those might be. I'm going to rename or retype that as a sine 16, and then let's see if we can back into those values. Likewise with temp A1, that's going to be our Y value. And so then looking at what is being said along the way, VARS3 appears to be we're saving off the current Y value so that we can use it in the next iteration and kind of increment through height, or in the case of X, increment over the length of whatever this function is trying to draw or check the collision for. So I think that we should just be able to reuse Y, and we can watch the coverage along the way and see if that, or the match along the way and see if that stays the same. I'm going to, because I know that VARS3 is set to Y, and then it's not set again, it seems safe to me to change this to a plus equals, and then we can just get rid of that value altogether. And the same thing with VARS4, and that's just going to be X. It doesn't really save anything here or there, or get us much closer, but it seems more correct. Likewise with this this temp A0, it is, these are going to be, it looks like XY pairs. And so we can, let's get rid of some of the other noise here and rewrite this as a for loop. This will allow us to get rid of var s0 and temp v0 at the same time. I do want to be careful though and make sure that those aren't being used. So temp v0 is here. And then so here we're dereferencing the current value of rs2, and then looking at the value that's 2 ahead of that. So these are going to be xy points. So likely one of these, like a 0.16 structure. It is possible that they are unsigned, in which case I don't know if there's a U.16 structure. But I'm going to switch this for now to that. Which would make var2 a pointer to 0.16s. And here I'm going to try to get away without using this pointer directly and just go directly to arg0. So that'll be the ith element of var0. It's x and it's y. And then all of this gets to go away. And so logically this is going to be equivalent. Is it the way that the original code was written, or were they iterating over a pointer? That's not necessarily clear yet, but looking at how these are done, it looks like this is correct. We'll see though along the way. We have some go-tos in here, and we can see if those are necessary. A lot of times I like to untangle the go-tos because either they're unnecessary or they the decompiler puts them in because it it feels that that's the most optimal way to execute that code. This is a little interesting, however. So we're for block 14, for example, if we would try to replace this, which is setting var s0_3 to 0, it'd be nice to know what that variable's for before we get too far into this. Then we have to bypass this else statement and fall down, making sure that we exit this loop along the way. So there's a loop here that we can try to untangle. But before that, I think I'm going to name some things. This one isn't going to go particularly fast. That's okay. So things like this are much easier. A go to block 23 is the same as just returning 0. And so looking at this loop down here, this one's a little easier. In all of the cases except, actually this return 0 is going to be at the bottom as well. So we're incrementing temp v0_2. And if it's greater or equal to 4, then we're going to return. And so that's our loop condition. So we need to see where that's being set and how it's being set. There is some complication along the way with var s0_3, which looks like it's going to be our I value. We could change this to a do while for now, which may more accurately represent the way that this was written. But it may just be a standard for loop. So if we put the condition like that, that should be equivalent. Let's look at what this... so if the velocity is greater than 0, we're going to execute all this code. Otherwise, we're going to return 0. I'm going to see if we can invert that and just return 0 right away and get rid of a bunch of this nesting. I don't think that changed the match at all. Var s0, we use that as I earlier, so we can get rid of this. Temp v0, we got rid of that as well. So it looks like we have a flag here that's being set except in this condition, and then being compared to 0. When there are cases like this where there's conditional checks as well as some assignment that's happening in line, it's likely that these were nested conditions, but without untangling this go to block 13 part, I'm not comfortable yet trying to untangle those, because we want to make sure that the logic stays the same. Howdy, Eldritch. Nice to have you back. We were, at the beginning of the stream, setting breakpoints and trying to figure out what some of the functions were. I should actually go through a lot of the randomizer documentation and implementation, and I'm sure you guys have documented many of the offsets for different functions that we just don't have names for in the Decomp project. We found some of the debris falling down. We found the function which does the effect for the background during the Dracula fight in ST0. It would be fun to go through some of those as well and tweak them and see what other effects we can get. Maybe I'll do that over the weekend and come back with something like that. Alright, so we still have a lot of garbage. So far, A0, that was the one we were looking at. So it's a flag that is being checked. And we're going to fall out of this loop when that value becomes false. I'm going to go, we can get rid of temp v1, it looks like. So that's a check of the collision effects. And even this, this pointer to collider, we can get rid of that first. Actually, I won't get rid of that. We'll switch this to treat it as a pointer. Down here, the compiler didn't know, or the decompiler didn't know what the type was. This would be incorrect though, regardless. So it said that it was a void star pointer, and every time it's incrementing that pointer, it's going to do so by 24, but it means 24 bytes. But a void star is a 32-byte. Oh, maybe it is 8, or maybe it is 1 byte. I'll have to look that up. That's actually pointer arithmetic. I don't know. In this case, we know the type of the pointer. The type of the pointer is a collider, and so we can just increment it. And doing the plus equals 24 is 24 colliders later, which is not something we want. I'm going to rename this var S1. I'm just going to call it collider P. And now we can get rid of this temp v1 because it's just looking at the effects. This is a random function from st0, which is the prologue when you play as Richter. I just chose the smallest function today. I'm not sure specifically what this one does. So here we're checking this value against 1. So it looks like we can increment this value with a post increment here, and only have to worry about var v0. So let's look at that and see if that's the case. This being shifted one way or another hints to me that var v0 is a it's a 32-bit value, and then it's being cast basically as a 16-bit value, or the opposite, one of those two. Let's look at what the decompiler thought it was. Okay, so it's treating it as a 32-bit value. I think this can be reused as I. One of the things that needs to be that I need to be cautious about here. We got rid of this loop 16. So here we're setting that value to 0, and it's being set to 0 in a funny way by taking 0 and shifting it left by 16 bits. And I think that's just the cast that's happening. So I'm gonna see if we can just get rid of most of this. This being a function that isn't actually called anywhere, it's unlikely that this function exists in the PSP version, so we can't rely on that to get some more details about what this might be. This, oops, this temp v1 underscore 2, that's going to be unnecessary. This temp s1 is also going to be unnecessary. So we're battling against what the decompiler thinks, but the decompiler is battling against the optimizations that GCC applied. So we have two things to fight against here. So arg1, we haven't used that up until this point. When a value is masked against FFFF like this, it was a 32-bit value being treated as a 16-bit value. My guess is that it came in originally as a 16-bit value, and this is going to be unnecessary. And we don't see the mask here in the decompiled, or the assembly. So then we have a bunch of funny business here, and effectively this is just incrementing I. And I think this is enough to reveal the for loop then. So we can change this to let's see, this is a little different. While I is greater or equal to 4. I wonder if I screwed that up earlier. We can look at the decomp and see. I'll give that a shot though. And we can look back here. That did get us quite a bit away from where we were. Yeah, that was incorrect. So this is going to be less than 4. I'm still curious why this ended up being so different. I will back that out and we can make it a do while. Yeah, I didn't like that either. Let's see how far back we need to go to get something that likes more. It looks like that at some point there is the value is being used as a 16-bit value, and so maybe I wasn't the value that was being used in this particular loop, but another value. So in cases like this, comparing that value directly to the 32-bit value seems to improve because it doesn't need to do a shift. I can replace some of these, which should help. Or at least not hurt. And I'm gonna redo that. So that looks to be correct. I'm going to see if I can create another variable to iterate over. Yeah, this looks better. Well, not perfect, but yeah, not sure exactly what's going on there, but that's better than it was. I may end here, and this will have to continue. I was hoping this one would go a little faster, but we've been at it for about 30 minutes, and there's still some complication around here. This'll fall out as it's rewritten, and likely be a relatively straightforward loop. Just with the go-tos, it seems less obvious what might be happening. I could spend a little time here. I probably won't do that because I'll get into the weeds, and I don't think it'll be terribly interesting. So along the way, I wasn't really looking at the assembly, mostly just trying to figure out the logic of this function, which is how I like to decompile, try to make it readable to myself first, and try to figure out what the intent of the code is, and then kind of go back and look at the details and see how types might need to change, how ordering of certain things need to change. And with the PlayStation version, that can be a little more complicated because things can be out of order, and it's just a more challenging decompile than the PSP. Excuse me, a little hoarse. So if you want to know more about the Castlevania Symphony of the Night decompilation project and our progress, you can go to soten.z.dev. There's a link to the GitHub repo where we are posting all the decompilation as we do it, as well as any refactors or other things like that. And then there's also a Discord channel where we're talking about decompiling SOTN, other decomps, and tooling, and all kinds of stuff related to this project. Eldritch is in the chat, and he does a lot of work in the SOTN randomization project, which is not taking decompiled code, but actually looking at the binaries and tweaking those to get some of the randomization and other tweaks that they're able to do for tournaments and other playthroughs of the game. And their stuff is in the Long Library Discord. So if you want to know more, go to soten.z.dev. If you have anything in particular that you'd like to see or like me to cover, feel free to chat. Make sure you follow. If you want to look at old streams where we've kind of gone end to end and gone from assembly to checked in code, or at least code submitted for a PR, those are either, I think the last 14 days is on Twitch, otherwise you can look for Made Up of Wires on YouTube. If you've been watching the channel for a while and are listening now, I like to play 3 different Nine Inch Nails CDs in the background. They're all Creative Commons licensed, so I can kind of safely play them without getting copyright strikes. And I don't know how I missed it, but I learned last night that Nine Inch Nails is going to be doing the soundtrack for the 3rd Tron movie, and just the 15-second teaser that they did at Disney Expo a few weeks ago was epic, and I'm looking forward to that a lot. You probably won't hear any of that on the stream, however, because that likely will not be Creative Commons licensed. So yeah, thanks for watching, and I'll be back on Monday and doing more decomp. Hopefully we have some more weapons finished at the time. I'm not sure. We're down to 12. I'm not sure if it's going to be finished next week, but it's getting close. There's still data to do for weapons, but weapons code is almost done, and hopefully will be relocatable soon. All right, that's it. See you on Monday.